Hello, this video is going to take a look at these energy bar charts again, only this is going to look at just specifically an open system. Right, I've done one of these in the video that's called pie charts and bar charts, what's the diff, right? Looking at the difference between them. But I'm going to look at a few more examples real quickly in this video, at least relatively quickly. What I want to take a look at, I'm just going to kind of go back to this same worksheet again. I've done a few problems off of choosing the system. Right, there will be other examples and some things out on Canvas to look at, and these are all going to be grouped together, so they should be pretty easy for you to see which one you need to work on if you have a specific issue. You're looking through some of these videos and things. The answers will be put out on Canvas for the practices, and we'll talk more about that in the near future also. But I just want to take a look at number 3. A rubber band is stretched and shot upward to the top of its path. And for this, we're looking at the open system. So we're looking at where the person is being taken out of the system. So once again, with these LOL diagrams, these circles represent the system. So if the person is not part of the system, the only objects left are the rubber band and the earth. Earth and rubber band earth. And we need to decide at which kind of parts or sections or which part of these interactions are we going to be looking at in terms of what's going on. So for this, let's look at the rubber band. Let's just look at it before it's stretched. And while it's stretched at the bottom, right? So it's at the bottom of its path. It's all stretched out, being ready to be shot up. And then let's look at the top of path. So these are the 3 areas. Oh, I may not have left enough room for my bars here. We'll see when we get there. So before it is stretched, and it's just being held there, right? If our system is just the rubber band and the earth, there is no energy at all in either the rubber band or the earth, as it's just being held in someone's hand before it's being stretched. When it is being stretched at the bottom, there is definitely elastically stored energy inside of the rubber band. And when it's at the top of its path, there is definitely gravitationally stored energy in the rubber band, right, caused by the earth. So since the earth and rubber band are part of the system, there's definitely energy in this chart. There's definitely energy in this chart, but there is no energy at all in this chart. And these two, though, there are going to be elastic and gravitationally stored. So we will put elastically stored energy and gravitationally stored energy on our diagrams here. Right, there we go. And as we said, as this thing is stretched at the bottom, there's definitely elastically stored energy. Let me maybe put 4 bars of energy there. Right, since it's at the bottom, there is no gravitationally stored energy. Since it's not moving, there's no kinetically stored energy. You could probably say that, once again, since this is being stretched, there may be a thermally stored energy. Bar there, you could do that. I'm just going to say there's not a significant amount of energy stored thermally throughout this entire process. I have put that in problem statements before, and if that's the case, don't be adding any thermally stored energy in any of these bars. Right? If I'm stretching this out to have these 4 bars of energy that are elastically stored. Once again, we could say like halfway up, and halfway up, there would be no elastically stored energy in the rubber band anymore. As soon as it's released and it's gone back to its original form, now the energy would be just in the rubber band as it's moving, and the fact that it's above the earth, so there would be kinetic and gravitationally stored. But at the top of its path, we're going to assume since not a lot of it, or really any of it, is thermally stored, all of that energy is going to be gravitationally stored in the rubber band due to the earth. So for these last 2 parts anyhow, when it's fully stretched, it's elastically stored energy. Once it's at the top of its path, that's all been transformed into gravitationally stored energy. But once again, the question is, where did that energy all come from? And it came from the person that was doing the stretching. But the person is not part of the system. Right? The person, and I'm just going to start doing this too, we hadn't done that earlier. The person is outside the system. They're in the surroundings. And the person has to put the energy into the system by actually physically grabbing the rubber band and stretching it out. And if we put 4 bars of energy over here, saying there's 4 bars of elastically stored energy, that person had to somehow put those 4 bars of energy in. Wow, that's really kind of sloppy, so I'll put the 4 over here. Right? And it did happen to be chemical energy. So it's again, listing the person and listing the type of energy are kind of optional, but there's definitely 4 bars of energy put into the system by the person, and it's put into the system because they're not part of the system. Now, if we made this a closed system and put the person with each of these, right, the person's chemical energy would be one of the bars initially. And then the person would still have some chemical energy throughout the rest of this process. But since we're putting the person outside of the system, we're going to say the 4 bars of energy the person put into the system through their chemical energy, that 4 bars is probably a tiny part of their chemical energy. That 4 bars is what's now being elastically stored and then being gravitationally stored by this rubber band as it's stretched out and then reaches the top of its path. So let me do a couple more of these. All right, so here's a couple other ones with springs. I guess these all happen to have some elastically stored energy in. They don't have to necessarily. But for this one, we have a ball which is moving at the start. It just hits a spring, and the spring is pushed in. I did do this one in the video that is just the closed system one. So you can go back and watch that one, take a look at this one, and kind of see how these diagrams compare if you would like. So this one has the ball, the table, and not the spring. All right, so it's just ball, table. And I already have a few bars of energy diagrammed out here in terms of what we're starting with, and we're saying that this has 6 bars of kinetically stored energy as it's moving. Well, as it reaches here, it's not moving as quickly, so I don't remember what I did on the other worksheet. We'll just say 4 bars here. And it's slowing down, so we're going to say some of that energy became thermally stored. We're going to kind of do that with the thermally stored energy. All right, so far all of this energy was in the ball, it's moving, and now it's still in the ball and some thermally stored energy between the ball and the table because the table has slowed it down. Now this thing is going to slow and it's going to stop. Once again, the one thing that a lot of people do is they say, okay, it stops, it's now all thermal energy. Well, I don't think it's all going to be thermal energy, but there will be some thermal energy. Maybe it's going to go from 2 to 3. It would probably not be the worst thing if you said 2 to 4, I don't know, but the thermal energy is going to go up somewhat. I'm still going to leave the thermal energy inside the system because the thing that's going to get warmer is probably the ball and the table. Yeah, it's not going to probably leave that quickly. I mean, if you did this the next day or whatever, right, definitely that would be leaving the system also. But the majority of the energy that is not accounted for here is because that energy is now in the spring. It's elastically stored energy. But I'm not going to put it here as bars of elastic energy because the spring is not part of the system. If the spring was part of the system, yep, I would add those other 3 bars right there. But since the spring is not part of the system and the energy is in the spring, we're going to show that that energy left the ball table system and now came out as the spring. It is being stored as elastic energy. So once again, listing the spring and the elastic energy out here is kind of optional, but I want to do that just to make this clear. This shows that 3 bars of energy left the ball table system is now being stored in the spring, and it is being stored as elastic energy. So this is an example where there's no energy really going into the system. In an open system, energy is leaving instead. So let me just do one last one for an open system. So in this case, we've got a ball pushed down, it's stopped against the spring. We let it go, and there it's stopped again. This is missing an arrow for some reason. Halfway up, this is moving. All right. So once again, we have ball, ramp, earth. No spring though. Ball, ramp, earth. Okay, I'm just kind of taking a look here. Dum-dum-dum. Dum-dum-dum. Okay, I'm going to need to modify these bars a little bit because this does say the ball continually slows down until it stops. So I'm just going to kind of work backwards with this one. So at the very top, if it's got 4 bars of gravitationally stored energy, Actually, sorry, I just had to second guess myself in my brain a minute. So that's okay. We have 4 bars of gravitationally stored energy. The reason this ball is slowing down is because some of this kinetically stored energy is turning into gravitationally stored energy. I was debating about whether or not I would add some thermal energy, and we could do that. But in this case, I think I'm just going to leave it the way it is. So halfway up, we have 2 bars of gravitational and 2 bars of kinetic because it's moving. Right? As it's gone to the top, this kinetically stored energy has shifted over into the gravitationally stored energy because it's now at the top of the hill. Once again, people have a tendency to say once something stops, it's all thermally stored. But in this case, no, this is at the top of the hill. So there is gravitationally stored energy inside of that object. Okay, so once again, if we have this energy, which is gravitationally stored, here it's kinetically stored and gravitationally stored, where did the energy come from? And it came from the elastically stored energy in this spring. And once again, if the spring was part of the system, then I would just draw my 4 bars of elastically stored energy, put it right here, and it would be perfect. But since the spring is not part of the system, right, the spring is outside of the system, that spring had to add those 4 bars of energy in. 1, 2, 3, 4. And once again, it was elastic energy, elastically stored energy. 1, 2, 3, 4 bars of energy the spring is putting into the ball and rampant earth, and then it's transforming into these other energy storage types. So open systems have energy that's flowing into the system or energy that's flowing out of the system into different objects that are not part of the system. In both of these cases, it happened to be a spring. Right, in the other example I did before, it happened to be a person that was putting energy into the system. But there has to be some object which is outside of the system, which is interacting with the system. And then this model is how we show that happening. Thanks for watching.